Good morning to all. This is Keerthana. So, welcome to today presentation on deep learning. So, today we are going to dive into the fascinating world of artificial intelligence and explore how deep learning is revolutionizing our understanding of machines and their capabilities. Right. So, first of all, we have to understand what is artificial intelligence. So, the artificial intelligence to explore to explore the fascinating world of AI from the basic concept to its real world applications. So let's start with the basics. What exactly it is artificial intelligence? So an artificial intelligence or AI is the simulation of human intelligence processed by the machines and especially computer systems. So the history of AI dates back to the mid 20th century. From these conceptual beginnings to its recent advancements, AI has undergone significant evaluations. So there are some key milestones are available in that AI. So the key milestones include the development of early AI programs, breakthroughs into a machine learning, and then rise of deep learning techniques. So to understand AI in better, to explore some basic fundamental concepts, right? So the machine learning is a subset of AI that enable machine to learn from data and improve over time without being explicitly programmed. So the machine learning is a subset of AI. So here I mentioned machine learning is a study of algorithms that learn from examples and experience instead of relying on hard coded rules and make predictions on new data. So before we move into the deep learning, we find what is neural network. So the neural network is inspired by the structure of human brain or a fundamental component of deep learning. The consists of interconnected layers of nodes that process informations. We discuss some applications of AI. So AI has countless applications across various industries. Let's take a look at some of them. So the first one is a healthcare. So in healthcare, AI is revolutionizing diagnosis, treatment planning, and drug discovery. Uh, in everyday life, from virtual assistants like Siri, Alexa to recommended systems on platforms like Netflix, AI is seamlessly integrated into our daily lives. So in this ethical and social implications. However, with the great power comes and great responsibilities. So that AI raises important ethical and social considerations. So here I just mentioned some examples of ethical issues in AI. These include concerns about the bias in algorithms, privacy violations, and then potential impacts of jobs and then economics likewise. So that future of AI, looking ahead, the future of AI holds both promise and challenges. Then, what are the emerging trends in AI? Advancements in explainable AI ethics, and AI safety are shaping the future landscapes of artificial intelligence. So, these kind of things are transformative technologies is vast potential to improve our lives by understanding its concepts and applications and implications. So, we have harnessed its power, responsibility of the benefits at all. Then what is machine learning? So machine learning, so what exactly is machine learning? Well, it's a branch of artificial intelligence that learn enable computers to learn and improve from experience without being explicitly programmed. So why we need of machine learning? It is important. So machine learning is incredibly important because it allows computers to handle complex tasks that traditional programming methods struggle with. Program recognizing speech to driving cars automatically. Machine learning is a revolutioning various industries. Like here, I mentioned the types of machine learning. There are three main types of machine learnings. Are in this below slide, I mentioned the types of machine learning. So the first one is a supervised learning, and then the second one is a unsupervised learning, and then the third one is a self supervised learning, and then the fourth one is a reinforcement learning. So the first thing, supervised learning involves the training model on labeled. The supervised learning in this supervised learning involves the training a model on labeled data, and then the unsupervised learning discovers patterns in unlabeled data and reinforcements learning through the trial and then error. Then how does the machine learning work? So at this core, machine learning works by feeding data into an algorithm which then learn patterns and makes predictions or decisions. So these predictions are refined over time as the algorithm learn from new data. Some of our daily everyday life examples of machine learning. What are the examples of machine learning in everyday life? You might not realize it, but machine learning is all around us. From personalized recommendations on streaming platforms of virtual assistants like Siri, Alexa, and machine learning algorithms are consistently at working our lives as easier and more efficient. So in this part, machine learning is a fascinating field with endless possibilities. By harnessing the power of data and algorithms, we can solve the complex problems and create innovative solutions. Whether you are a student and curious about the future of our future, or a professional looking to expand our skill set, and machine learning is a definitely worth to exploring. And the next thing is deep learning. So we are now in our discussion is deep learning. So that deep learning, so what exactly is deep learning? We already know about what is artificial intelligence and then machine learning. So now we are enter into the deep learning. So in that deep learning, so in that our understanding what is deep learning. So what exactly in deep learning? So at its core, deep learning is a subset of machine learning. So the AI machine learning is a subset of AI, and that the deep learning is a subset of one of the subset of machine learning, right? So the machine learning that focuses on training artificial neural networks to learn from data and make intelligent decisions. Think of it as teaching a computer to think and learn like a human brain. Here we discuss some animation of neural network. So just imagine our brain as a network of interconnected neurons, right? Similarly, a deep learning model consists of layers of artificial neurons. So each processing and transforming data to extract meaningful patterns and insights, right? Here some early versions of early artificial intelligence and strives excitements, and then machine learning begins from flourishes and deep learning concepts. Deep learning is a breakthroughs drive AI boom. And here we discuss some traditional machine learning and then deep end-to-end learning. So the first image is handcrafted features and learned classifiers, then finally it is a cat. Then the deep end-to-end to learning, first it is learned low level features, and then after it's learned the mid level features, and then after that it's go for the high level features, then finally learned classifier, and then finally the result will be produced, it is a cat. So this is the traditional machine learning versus deep end-to-end learning. Here I some private scale drives deep learning progresses. So the first in this red mark, it is a traditional learning algorithms. That means traditional machine learning concepts. And then after that we move into a deep end-to-end learning. So it's growing to the up level like large NN, large neural network concepts. So we we in some we discuss some applications of deep learning. So now explore some real world applications of deep learning, from image recognition and natural language processing to autonomous vehicle and healthcare diagnostics. The possibilities are truly endless. So examples of applications. So for instance, deep learning algorithm power voice assistants like Siri, Alexa, enabling them to understand and respond to human speech. They are also play a crucial role in medical imaging, helping doctors to detect disease like cancer or more accurately and efficiently. So let's start with deep learning. You might be wondering how can you get started with the deep learning, and well, the good news is that there are plenty of resources available online to help you learn and practices. Websites like Coursera so offer courses on deep learning for beginners. So there is an n number of platforms as available. So after that we moving the fundamental of machine learnings. So in this data part, that humans learn by observation and unsupervised learning model of the world, common sense of reasoning. So machine learning needs lots of data to compensate, that means labeled one. And then the sensors generalized of matrices or to n dimensions. So the one tensors, 2D sensors, and 3D, 4D, 5D sensors. So up to uh, training, validation, and then test splits plus adversary test, and then mini batches. The small sets of input used to time usually processed independently. So these are the anatomy of deep learning, deep neural network. So the first thing is a layers, and then input data and targets, then loss function, then optimizes. So the first layer is a data transformation, and then these are the input path, and then predictions, and then and then it's moved to the predictions, and then loss functions. Then loss functions get the true targets or loss score. It's moved to the optimizer, and then finally it's moved to meet the weight of the updates. So the layers are data processing models, and many different kinds of exist, decently connected and convolutional recurrent, pooling and flattering and merging and normalizations and etc. So it's like input one or more tensors or output one or more tensors. Usually have a state encoded with weights and learned initially random. When combined form a network or a model. The input data and their targets. So the next one is a input data and a targets. So the networks maps or the input data x and predictions is y. During this training, predictions y are compared to the true target y using the loss functions. So this is the first layer is a input, the layer one data transformation, and then in this x input is through the layer data transformation through the predictions form. Then what are all the deep learning frameworks are there? So examples like Kefi, PyTorch, Torch, Chainer, and then Kefi 2, deep learning 4J, TensorFlow, DML, C, and MaxNet, the ANO, so the K. So these are the things are deep learning frameworks, right? So in this, so these are the deep learning frameworks. So the first things first. So let's understand. We already understand what is the what are all the deep learning frameworks available in nowadays. These are the software libraries designed to streamline the process of implementing execute deep neural networks. They provide pre-built functions and modules for tasks like data manipulations, model creation, and optimizations. So examples of deep learning frameworks logos, like some of the most popular deep learning frameworks already we discussed here: TensorFlow, PyTorch, Keras, and MXNet, each offering unique features and advantages. So here we just discuss some of the frameworks. So the first one is it TensorFlow. So let's start with TensorFlow, developed by Google Brain. So TensorFlow is an open source platform known for flexibilities and scalability. It provides a comprehensive ecosystems for building and deploying a machine learning model to across various platforms from desktops to mobile devices. So there are some key features are available in this TensorFlow logo. With the TensorFlow, developers can easily to create complex neural networks. So thanks to its high level APIs to extensive documentation, it's also offered tools like a Tensor's board for visualizing and monitoring models performances. The second thing is a PyTorch. So we have PyTorch developed by Facebook AI Research Lab. PyTorch has gained popularity for its intuitive interfaces and dynamic computations graph. Unlike TensorFlow, PyTorch uses a define by run approach, allowing for more flexibility to easier debugging. So the PyTorch logo and key features are: it's widely used for academic and industries for its simplicity and ease of use. It provides a seamless transition from a prototyping or productions, making it a favorite among researchers and developers alike. So next we move into the Keras. So now let's talk about Keras. A Keras is a high-level neural networks API written in Python and capable of running on top of the TensorFlow. So Microsoft Conjunctive Toolkit, it is known from it is a user-friendly interface and then simplicity, making its deal for beginners and experts as like. So the Keras logo and their key features are: so it's abstract the way of complexities of building a neural network, so allowing user to focus on the model designing and experimentation. It's perfect to rapid prototyping and then experimentations. And then the final thing is MXNet. So the last but not least, we have MXNet developed by Apache. MXNet is a flexible and efficient deep learning framework that supports both imperative and symbolic programming. And then it's known from its scalability and performance, making it suitable for large scale distributing trainings. So in that MXNet's logo and their key features are: so MXNet is a comprehensive toolkit to include models for computer visions and natural language processing and reinforcement trainings, like making its versatile choice of wide range of applications. So these are the things are mainly in nowadays they are working with these kind of frameworks in deep learning. So in their requirement, their frameworks will be changed based on these requirements. So the deep learning frameworks play a crucial role in advancing the field of artificial intelligence. Whether you are a researcher or a developer or a hobbyist, these tools empower to analyze the fulfill potentials of neural networks and drive innovations and forwards. Okay, so now we understand some of what is artificial intelligence, and then what are the applications are available in nowadays in artificial intelligence, and then we know about what is machine learning, and then what are the machine learning concepts, and then their features, and then example applications we discussed today. And then finally we move into the deep learning concept. In this deep learning we discussed what is deep learning, and what is the history of deep learning, and then what is the and then what is the neural network frameworks, then how the input is processed to the next one, and then we can just compare it to what is machine learning and then end to end deep learning. So we discussed in those things, and then after we move to the examples of applications of deep learning, then getting started with how to start with deep learning. Then we discuss some frameworks as like PyTorch, TensorFlow, and then Keras, MXNet, and then their key features. So these are the things how they are executed, and then how they executing their features. So next, in the final in this final conclusions, so the deep learning holds immense potentials to transform industries and drive innovation across the globe. So by understanding its principles and applications, we can unlock new possibilities and pave the way for a smarter and more connected future. So thank you all for today. Thank you.